Most people think AI coding assistants fail because they're unpredictable. That's not the real problem. The real problem is that we give them power without giving them rules. In this lesson, you're going to see why structure matters more than prompts, why speed without control creates chaos, and how professionals actually work with AI instead of fighting it. This is Lesson 13, where we stop treating AI like a chatbot and start treating it like a machine. AI coding assistants are powerful, incredibly powerful. They can write code, refactor systems, create, modify, and delete files on your computer and servers almost instantly, generate entire features in seconds. So let's be precise about what we're dealing with. Coding assistants like Claude Code and others similar are not chatbots. You have to envision a coding assistant in another way. You need to envision it as it actually is, a very powerful machine. A machine that will do exactly what you ask it to do. Again, and that's where most problems begin. Now, imagine turning this machine on without touching the controls. You give it a vague instruction. Improve this code. Clean things up. Refactor the backend. The machine doesn't hesitate. It starts moving. Everywhere. Now, the movements of this metaphorical machine are extremely exaggerated, but they show the very true nature of an AI coding assistant, unbounded. It edits files you didn't mention. It introduces new abstractions. It breaks tests you weren't even looking at. It creates files, directories, and tests that weren't asked for, not because it's reckless, but because you never told it exactly what to do and where to stop. If you've used AI for coding before, this moment feels familiar. You look at the diff, and you think, why did it touch that file? Where did this abstraction come from? How did this even break? This isn't an AI problem, it's a control problem. You gave the machine power, but no operating procedure. This is where the PIV loop comes in. Plan. Implement. Validate. This is not a productivity trick. It's an operating procedure. Plan defines intent. Implement allows controlled execution. Validate proves nothing unexpected happened. Without this loop, you are guessing. With it, you are operating a system. A structured prompt is not a request. It's a control panel. 4 sections. Same every time. First, context. Tell the AI what kind of system it's working in. The architecture, the patterns, the libraries, where features live. Second, task. One small job, one loop, not a rewrite, not a redesign. One specific change. Third, constraints. This is the safety cage. Which files may be edited? Which files must not be touched? What conventions must be respected? Fourth, validation. This is non-negotiable. Which tests must pass? Which commands you will run? What output confirms success? These 4 sections don't slow the AI down. They focus its power. Here is an example. We are going to give our coding assistant a detailed prompt characterized by the 4 sections we have just discussed. First, you tell the coding assistant generally what you want the assistant to do. You are helping me extend a fast API backend for an app called Agent Workspace. Next, you give it context. Architecture, core, shared, features with vertical slices. This feature belongs in features/workspaces, DB, Postgres plus SQL Alchemy, tests, PyTest. Next comes the task. Add an endpoint, get/workspaces/search query. Match by substring on workspace name, case insensitive. Return the same response schema as the existing list workspace's endpoint. Then comes the constraints. Only edit files under Features, Workspaces /. Follow existing patterns for router, service, repository. Add tests covering search returns multiple matches. Search returns empty list for no matches. Query shorter than 2 characters returns 400. Last, the validation. At the end, list all files changed. Tell me which PyTest command to run. The codebase that was produced from this prompt request to our coding assistant is in our series repo on GitHub. The URL to my series repo is in the description below. However, the example codebase you get from running this prompt might tend to be somewhat different than what I have provided in my codebase. You might use a different coding assistant, for example. However, any codebase from this detailed prompt should produce very similar results. Let's focus in on validation a little more. We can see tests run, types check, lint passes. Validation is not about trust. It's about verification. This is how you know the machine did what you asked, and nothing else. This is also how we know it is safe to move on to the next piv loop in creating our overall agentic AI application that we might be working on. Now look at the machine again. Same power, same speed, but now it moves with intention. This is what working with AI actually looks like. Not chaos, not fear, control. You don't need to make the AI less powerful. You don't need to fight it. You need to give it boundaries. That's how professionals work. And that's how real velocity begins. This lesson has shown that boundaries are so important in a way that most of us can relate to. In the next lesson, Lesson 14, we will talk about safe tests on the front end. Don't miss it. Also help us out. Subscribe to the channel and hit that like button. In this way, all of these lessons will be available to more viewers interested in becoming better agentic AI strategists and developers. Ring that notification bell so you know when this valuable lesson will be here on YouTube. Thanks, and see you in Lesson 14.